Previous slide. Which slide you are looking for? These laws are not there in your curriculum, that's why I am escaping. Yes. Okay, this slide you are looking for? Okay, yes. Yes, this is the slide that a teacher's salary and the consumption of liquor. So these are the things which is high correlation does not mean so. Let's move straight away to the next unit. Regression analysis. Correlation analysis helps the manager in understanding the relationship between the two different factors. Like if you are in the marketing, and if you want to see whether the whether sale of if you are selling some particular product, and if you know the behavior of that particular area, and if you want to understand if is there any correlation with the behavior of that particular area, society and the product, that one can understand. So correlation is very important characteristics, and you can use it. This is being used by the managers in understanding the behavior of and the dependency of the things, product, whether the new product is going to depend on others or like that, with different phenomena, characteristics and all these things, if one can understand by using the correlation analysis. So managers are using these techniques, and more or less they are using these techniques and for the forecasting purpose also. So this is all about the correlation analysis. Let us come to the regression. What is the dictionary meaning of regression? What is the dictionary definition of regression? Regression means going backward. If you will open the dictionary, you can come to see that regression means going or moving backward. Going back to the previous condition, that is the meaning of regression. Going back to the previous condition. We have taken an illustration, Tolman's sons. There are two types of regression is there in regression. One is multivariate regression. Another one which is there in our curriculum, that is bivariate regression. Bivariate regression is measure of linear association that investigate a straight line relationship, and this bivariate regression is useful in forecasting. Linear association that investigate a straight line relationship, useful in forecasting, bivariate regression. So that is very easy way to understand bivariate regression. Bivariate regression means as we have already told, if you will refer, measure linear association that investigate a straight line relationship. So you know the measures of linear association that investigate a straight line relationship. Straight line equation all of you are knowing, y is equal to mx plus c. So that you have already used in the time series a plus bx, where y is the dependent variable, x is the independent variable, a and b are two constants to be estimated. So more or less, if you will see the regression, you have a means an intercept significant of a line, an intercepted significant of a line, that is called a. The point at which a regression line intercepts the y-axis, the point at which the regression line intercepts the y-axis, you know, if you are drawing a line, it is cutting the y-axis at a particular point, that is called a, the intercepted significant segment of a line that we used to call. And b is the slope. Slope is the inclination of the regression line as compared to the baseline. Sometime you can see the inclination of regression line as compared to the baseline, no, rise over run. As your b, the value of b is more, it is rising up, and if it is the value of b is less, then you can slope is lesser, so then the profit is less. So this is slope is showing how the profit will go up and down. So the inclination of regression line as compared to the baseline. You see here, we have took a very here you can see scatter diagram and eyeball forecast. Scatter diagram, you know, here two line. This is if you see here, the points are distributed. If you are you have taken the observations, so observations are, these are the points which you can see, that is the observation, actual observations are there during the time span of, say, this is the x-axis is there, and along y-axis whatever the value is there, xy, so the points has been taken. So suppose one can draw two different lines, because both lines are nearly more or less is same. If you will see, if you are drawing a line, it may be your line is there black, that line is also more or less is showing the trend of your distribution points, and my line is different, both are showing the trend more or less. So what is the difference between these two? Difference is the slope. In one case, if you will see in the previous case, in my line the slope is high and your line slope is less, means the value of b is different. So let us see what is this delta. See, this is the equation of, suppose I'm just, first of all I'm talking about your line. In your line, y is equal to a plus bx is there, and this is delta y, the difference between y1 minus y2 minus y1, that is delta y is there, and this is your delta x2 minus x1. And once you are taking the dividing them, you can get this is the things. Now what is happening? See, this is the next slides we are talking here. Y hat for the dealer 3 is this particular point, and actual y for the dealer 3 is this particular point. So now similarly, y hat for the dealer 7 you can get at this particular point on the line, whereas the actual point is here on the top, the point is there. So the y hat you will get on the trend line for the dealer 7, y hat for the dealer 7, and actual y you can, it is there, a point is there on the top, little bit up. If there was no such such influence is there, any influence is not there, in that case you will have a y bar, that there means throughout the journey there is no change. So a scatter diagram for explained and unexplained variations, y bar you can show a straight line and your line is this. Now say for example, if you will see a total, this is actual point here, and if there was no variation is there, then what is the total deviation? So actual point value, this is the y value, actual yi value, y value minus y bar value. So y minus y bar is called total deviation. So total deviation one can get by this is the total deviation, how one can calculate. For each and every point you are getting different total deviation, because yi is different. So if you want to take the total deviation, means take the sum of all the total deviations. Now this is the trend line. So here you have a y hat minus y bar. So y hat minus y bar is another type of deviation. This deviation is called deviation explained by the regression, because this is a regression line, you draw your line. So your value should be here. So this difference is the deviation explained by the regression. This is the total deviation and this is the deviation explained by the regression. Is it clear? Am I with you, friends? Are you getting me? What is total deviation and what is the deviation explained by the regression? Yes, getting. Okay, fine. Now let's see. Now there is a difference here. There total deviation, and there is a difference between total deviation and the deviation on the regression line. So that is the total deviation point minus the y hat, means yi minus y hat. Yi minus y hat is a deviation not explained. So total deviation is a sum of yi minus y hat. Y hat is a point which is there on your regression line. So yi is the actual point. Yi minus y hat, that is called deviation not explained, plus y hat minus y bar, that is deviation explained by the regression, that is called total deviation. So there is a different method in practice in the regression analysis. One of the method that we have already learned, this method is there in the case of correlation analysis also, least square method. Least square method uses the criteria of attempting to make the least amount of total error in prediction of y from x. More technically, the procedures used in the least square method generates a straight line that minimizes the sum of square deviation of actual values from this predicted regression line. So least square method, basically what is happening here, as we have already explained in the time series analysis case also previously, here in the least square method, a relatively simple mathematical techniques that ensure that the straight line will most closely represent the relationship between x and y. And in this method, our objective behind the regression is to minimize the, this is called simple linear regression model also. In this simple regression linear regression model, our objective is to minimize the unpredicted random element. Here ei is there, sum of I is 1 to n, ei is called unpredicted random element, usually called the error terms. Usually you can call it is an error terms, error, unpredicted random element. So if your equation is yi y is equal to a plus bx. So if you are adding y is equal to a plus bx plus e, so instead of calling equation as y is equal to a plus bx, between the given variable, the variable to be predicted is called the dependent variable is y, and the x is called the independent variable, and the variable on which the prediction is based, that is called independent variable. So simple regression line, one can assume y is equal to a plus bxi plus e, where y is dependent variable, xi is the independent variable, and ei is a unpredicted random element. Our objective behind the least square method is to minimize the square of the unpredicted random element. Why we are taking the square of unpredicted random element? Because if you are having only ei to reduce, then ei may be plus, may be minus. So if it is plus or minus, if you are taking the square of that, all the errors will become positive. So either the error is plus or minus. Objective behind that this is to nullify, to reduce the nullify effect of error. We are just squaring it, and then we are taking the sum, and finally our objective is to reduce the to bring the value of e square, that is e square is unpredicted random element value. The total unpredicted random element value have to be minimum. In this least square method, we have in the least square method, keeping in view of unpredicted random element have to be 0. What is to be done? We have to first of all say, for example, we want to do one exercise with the help of Excel sheet. Then it will be easy for us to understand. Very easy exercise, same manner as we have already done in case of in the correlation analysis. I am going to share you an screen, desktop. The moment this is the we are taking I am zooming it and bringing up to the level of 200, and I am taking the observation, total observation. Say for example, I am taking a total observation of 10 observations. Least square method I am going to do 3, 4, 5, 6, 7, 8, 9, 10, and we are taking the data of income data along x-axis, and along y-axis we are consumption expenditure data we are taking along y-axis, and we have just collected the data. Income is in 1000 rupees. Say for example 41, 65, 50, 57 is there, 96 is there, 94 is there, 110 is there, 30 is the income, 79 is the income, and 65 is the income given, and their corresponding expenditure in thousand root dollar is also given. 44, 60, 39, 51, 80, 68, 84, 34, 55, and 48. We want to do the, first of all, our objective is to, for the summation purpose, if you will plot this income and expenditure data in the form of graph, this is actual data. So if I want to plot a graph, let me check the insert a scatter diagram, point diagram. Let us see how it is. This is the distribution. From this graph you can say the trend is showing straight away. So we can draw a line also, a scattered line also. So we want to, first of all, we want to draw a line. So what, first of all, we want to find, these are actual points, that is xi, yi are there with blue dots. And first of all, we will draw a, we will try to find out a regression equation, and then we will draw a regression line. Then we will try to calculate the total weight deviation, unexplained deviation and explained deviation. That is the target we have with us. Let us try to, first of all, we have to find the same manner. What is the total regression here? For the purpose of that, we will use the more or less same equation. The equation is yi sigma yi is equal to the n into a. In the putting, just you put the value of least square regression formula. What is the least square regression formula? Is sigma y sum y is equal to n into a plus b into sigma sum x, and then sigma xy is equal to a into x plus b into x square. Once you will put the value, and by solving this equation, what is to be done here? Let me calculate first. Let us assume this is your x, this is your y, and in the least square method, your equation is least square method. What two equations have to be followed? Sum y have to be equal to na plus b sum x, b into sum x. This is one equation you have to frame, and second equation have to be framed sum xy to, because it is a bivariate statistics, that's why sum xy is equal to a into sum x plus b into sum x square, sum x square. So you can generate these two equations from this, and easily, like equation 1 and equation 2, you can solve this equation and you can get the value of a and b. And once you will get the value of a and b, then putting the value of a and b in the equation, y is equal to a plus bt, a plus bx, you will get the a line, and that line will you will get in this particular domain. So let me calculate first xy for your, then we will calculate x square, y square, and then we will put in the equation this multiplied by this x square, this multiplied by this So we have already got it. Let us calculate this sigma x. What I am going to do is, we have already got this value. Now we can get two equation. One sigma y means 563 is equal to 563 is equal to 10, n is 10, 10a plus b into sigma x is 67, so 687b, 687b. This is your first equation, and second equation you are getting sigma xy is 42358 is equal to 687a plus sigma x square is 34223b. Now once you will solve these two equations, you will get the value of A value is you will get it is equal to 14, and you will get the value of B, that is equal to 0.616. So two different value you are getting, and then automatically you will get an equation of regression line. Your equation of regression line is 14 plus 0.616 x. This is the equation you are getting, and now based on this trend line I am just going to draw, I am going to put this we want to calculate this also. So let me do one thing. I am calculating the y hat by inserting one column here. We are going to calculate y hat, and then we will draw on the same equation. Y hat is equal to 14 plus 0.616, and then multiplied by the value of x, which is already here. So you will get a different value of x in this case, and these are things we have already got. Now we want to draw a line. Now we want to see the trend by changing this. We are inserting a scatter diagram. So red dots are the straight line, which is y hat is there. These red dots are, you can say, this is showing a straight line trend. Line we are not able to draw. So you are getting the y hat, like this is the red dotted lines are dotted points are the y hat points, and actually blue points are this. And what is the y bar value? The y bar, you will get a line, in a different line you will get it at different location. Y bar is a 56.3. So 56.3 is something you will get near to this particular point. So this is the points where you can get explained and unexplained variations. So how one can get, this is the way we can get, we can calculate the some other equations, and we can draw the line, a straight line. So this is the things we have already done. Logic behind this least square technique is, no straight line can completely represent the every dot in this scatter diagram. There will be a discrepancy between the most of the actual across and the predicted scores. Use of attempting to make the least amount of total error in prediction of the y and from x. This is the things we have already done. We know how to calculate the value of beta, that we have already learned. And this is the things we have already used, the Carl-Pearson method for calculating. We have already learned how to calculate the value of A, how to calculate the value of B, and then finally we got the equation. This is the equation. We have learned how to get the equation for a particular point, and we have already calculated the y hat for all the 10 observations there. So you have already seen how, what is the value of y hats, and the errors also you can get it. So 0.5 is the error. How we can calculate? You have the y value, actual y value, and the y hat value, and from there you can get the errors. For you can get the error of all the errors, take the squares, and then finally for all the value of squares, then you can calculate the minimum value we have to bring. So this is all about the correlation and regression chapter. So we have completed this chapter, how to get it. Kindly do the illustrations, whatever is there in your book. So we finished this chapter, correlation and regression.